Okay, good morning, friends. I'm going to start with the next chapter today, that is chemical kinetics. You see, chemical kinetics is that branch of chemistry which is mainly dealing with rate of a reaction. What do you mean with the word rate? Rate actually means speed. When we are traveling from one place to another, we say that this much distance is covered in this much time, and then we calculate the speed, the distance covered divided by time taken. So here when we are talking about chemical kinetics, it is that branch of chemistry which is mainly dealing with study of rate of a reaction, that means speed of a reaction, mechanism of certain reactions, and what are the various procedures and phenomena which are taking place during any chemical reaction. These all things we are studying under chemical kinetics. The first important term under chemical kinetics comes the word rate. What do we mean by the word rate? Rate means change in the concentration of reactants or products per unit time. That means when we are starting a particular reaction, A changing into B, what will happen? The concentration of A will gradually decrease and concentration of B will gradually increase. So in terms of A, we can write down decrease in the concentration of A divided by time taken, or we can write down increase in the concentration of B, that is products, divided by time taken. Since the concentration of the reactants is gradually decreasing, and you know rate is always positive, we put a negative sign before it, because that negative into negative becomes equal to positive. So a negative sign will be put before the rate of a reaction for reactants, because their reaction is gradually decreasing. Then we will plot a graph. If we plot a graph between concentration of reactants and products, the product with time, we will see that we get different the graphs which we observe, you will see that they will be different graphs. For a concentration of reactant, the graph will be something different, and for concentration of products, the graph will be different. For example, for the reactants, the graph will be this, because the concentration of reactants is gradually decreasing with the time, and the concentration of products is gradually increasing with time. So this will be the graph which will be plotted between concentration of products and time, and this is the graph between concentration of reactants and time, because the concentration of reactants is gradually decreasing with time. So we have a graph like this. So what is rate? Rate actually means the speed of a reaction. Okay, next important thing is there are some reactions which are very fast and some reactions which are very slow. For example, one example of a slow reaction, we had done rusting. Rusting takes around 10 to 12 days. Formation of coal takes a long time. So they are slow reactions. Some reactions are instant reactions. जितने भी हमारे आयोनिक reactions होते हैं, सोडियम क्लोराइड को आपने सिल्वर नाइट्रेट के साथ रिएक्ट कर दिया, फौरन एक पीपीटी बन जाएगा, white PPT of AgCl will be formed. So this is an instant reaction. Now, rate, which we have clearly understood, may be defined as change in the concentration of reactants or products per unit time, decrease in the concentration of reactants per unit time, or increase in the concentration of products which are formed per unit time. What will be the unit of rate? Rate is change in concentration per unit time. तो change in concentration हम कैसे मेजर करते हैं? मोल्स पर लीटर में, और टाइम हम किस में मेजर करते हैं? सेकेंड्स में. तो यूनिट क्या हो गया रेट का? मोल्स पर लीटर पर सेकेंड, या मोल्स पर लीटर पर मिनट, या मोल्स पर लीटर पर आवर, डिपेंडिंग ऑन द यूनिट इन विच वी आर टेकिंग द टाइम. नाउ रेट्स आर ऑफ टू टाइप्स, एवरेज रेट एंड इंस्टेंटेनियस रेट. एवरेज रेट एंड इंस्टेंटेनियस रेट में क्या अंतर है? Average rate is the total change in the concentration of the reactants or products per unit time. What is instantaneous rate? Instantaneous rate is the rate of a reaction at a particular instant of time when the time interval is very small. We can say that t approaches 0. Delta t means change in the time. And how do we represent the rate of a reaction? In order to represent the rate of a reaction, the average rate we write down delta t upon t will be equal to average rate. And for instantaneous rate, definitions I've already talked about. It is the rate of a reaction when concentration at a particular instant of time. So if we want to write down the equation, we can write down d by dt of R with a negative sign because it is a reactant, which will be equal to d by dt of P with a positive sign because concentration of products is increasing. Instantaneous rate क्या है? The rate of a reaction at a particular instant of time. In order to measure that rate, we take a particular instant of time and then we draw the curve to it. Okay. Then how do we find out? What are the different methods to find out the average rate and instantaneous? Now, in order to find out the instantaneous rate, what do we do? हम किसी एक रिएक्शन को कैरी आउट करते हैं, कोई भी पर्टिकुलर रिएक्शन हमने ले लिया, एंड आफ्टर कैरिंग आउट दैट रिएक्शन, आफ्टर एन इंटरवल ऑफ से we divide the time interval, so 2 minutes, we remove the concentration of the reactants, freeze them and note down their concentration. So again after 2 minutes, so after a gap of 2 minutes, yeah, 5 minutes, that depends on us, we collect the concentration of the reactants, note it down, and then we further continue the reaction. So we have two things now. We have concentration and time. Then we plot a graph. Since this is the graph of reactants, the curve which you see will be like this. We plot a graph between concentration and time. We get a curve like this. Now, in order to measure the instantaneous rate at that particular instant of time, हम क्या करते हैं? हम एक tangent draw करते हैं curve को at that particular time, and then we extend this tangent on both the sides. X axis को भी कट कर दे और Y axis को भी कट कर दे, तो this whole divided by this gives you the average rate, that is total change in concentration divided by total time. Slope of the curve, here I have written slope of the curve gives you the rate of reaction. In order to measure instantaneous rate, again the same thing is done. A reaction is carried out for some time. After regular intervals of time, the concentration is removed. There are some reactions whose change in the concentration may not be measured. They may be measured by change in pressure or change in volume. So depending on that, we can carry on the reaction. We can measure the change in volume. We can measure the change in concentration also. Then we again plot a graph between change in the concentration of the reactants and time. And in order to measure the instantaneous rate, for the average rate, this was calculation of instantaneous rate. We calculate it, we plot a graph between concentration and this. At that particular time, say 10 minutes or 5 minutes, we draw a tangent to the curve and cut it on both the sides, on the x-axis and y. This whole distance covered, या हम कहेंगे the change in the concentration divided by the time taken gives you the instantaneous rate. Now, in order to measure the average rate, two definite time intervals are taken. To calculate the instantaneous average rate, two particular time intervals are taken. For example, in this, I have taken 10 minutes and 15 minutes. Then at 10 minutes, what was the change in concentration? This is measured here. And at 15 minutes, what was the change in the concentration? Then x2 minus x1 divided by t2 minus t1. This gives you the average rate. The time interval which we select, we write down delta t approaches 0. That means the time interval should be very, very short. This is another example I have given. I have taken two time intervals. One is at 10 minutes, this is the concentration. Another at 15 minutes, this is the concentration. Change in concentration divided by time taken gives us the average rate. Now, if the same thing we carry on, suppose instead of measuring the concentration of reactants, I measure the concentration of products formed. Then what will happen? Then we will again plot a graph between concentration and time, and since it is products, the curve will come out like this. In order to measure the instantaneous rate, again we will at that particular time we will draw a tangent to the curve and extend it on both the sides. Change in the concentration divided by time taken gives you the instantaneous rate. Now, in order to carry on the average rate, again we select two different time intervals. Here I have selected 5 minutes and 10 minutes. At 5 minutes, what was the concentration? This is measured here. At 10 minutes, what was the concentration? It is this minus this divided by this minus this gives you the average rate. Okay. Now next, what are the various factors on which the rate of reaction depends? There are various factors. One is surface area. जितना ज़्यादा सरफेस एरिया होगा उतना रेट ऑफ रिएक्शन ज़्यादा होगा. इसीलिए अगर हमारे पास ढेले वाला नमक है और हमारे पास पाउडर्ड नमक है, तो पाउडर्ड नमक का रिएक्शन फास्टर होगा एज कम्पेयर टू द डेली. जो कोयला है, अगर हमारे पास पाउडर्ड कोल है, दैट विल रिएक्ट फास्टर एज कम्पेयर टू अ लंप ऑफ कोल. अनदर इंपॉर्टेंट फीचर इज लाइट. वो सारे रिएक्शंस जो फोटोकेमिकल लाइट्स है, मतलब जो लाइट के प्रेजेंस में होते हैं. हम लोगों ने मीथेन का प्रिपरेशन, मीथेन का रिएक्शन पढ़ा था क्लोरीन के साथ, विच इज़ अ चेन रिएक्शन. देयर आर डिफरेंट रिएक्शन, चेन इनिशिएशन, चेन प्रोपोगेशन. दैट वाज इन द प्रेजेंस ऑफ लाइट. ऑन द एरो वी राइट ऑन H nu. So all those reactions which are photochemical, that means they require light, occur in the presence of light. The first factor was surface area, second factor was light, third factor is concentration. More the concentration of the reactants, more is the rate of reaction. Next is temperature. It is generally found कि अगर हमने टेम्परेचर को 10 डिग्री बढ़ा दिया किसी भी रिएक्शन का, तो यूजुअली इट इज़ फाउंड दैट द रेट ऑफ रिएक्शन गेट्स डबल्ड. Then another बहुत important feature is concentration of the reactants, concentration of the products. I think we have discussed all the important that which were necessary. Now how do we write down the unifying rate expression? Suppose I have an equation A plus B, I have an equation 2A plus 3B giving you 2C and 4D. हम रेट को चारों के टर्म्स में लिख सकते हैं, पर हम उसको यूनिफाइंग कैसे बनाएंगे, एक रेट को दूसरे से कैसे रिलेट करेंगे? हम कुछ नहीं करेंगे. हम जो उसका कोएफिशिएंट होगा रिएक्शन का, उसको डिनोमिनेटर में ले आएंगे. फॉर एग्जांपल, अगर मेरे पास ये, तो हम लिखेंगे रेट इज इक्वल टू डी बाई डी टी, 1/2 ऑफ डी बाई डी टी ऑफ ए. 1/2 क्योंकि कोएफिशिएंट उसका 2 है, और एक नेगेटिव साइन लगाएंगे क्योंकि वो रिएक्टेंट है, इज इक्वल टू 1/3 of d by dt of B with a negative sign, which will be equal to 1/2 of d by dt of C, again with a positive sign because it is a product, and similarly 1/4 of d by dt of this. This is said to be a unifying rate expression. किसी भी रिएक्शन में हमने एक रेट को दूसरे रेट से कैसे रिलेट किया, depend on that. Now based on this, I will give you the numericals which you have to perform. My next whatever topic I have to cover, that I will cover in my next video.